Okay, in this video, I'm going to start talking about inequalities that have to do with absolute values. Now, again, just like equations, I want you to take both cases. From the book, from our book, you can see that for an algebraic expression x and k is greater than 0, an absolute value inequality is an inequality of the form absolute value of that expression is less than k is equivalent to negative k, and it's less than k. And the same as the other way, the absolute value of the expression is greater than k is equivalent to being less than x, k, or x is greater than k. So I'm going to take both cases. In this example here, we have the absolute value of x minus 1 is less than or equal to 3. So I'm going to take both cases, and I'm going to show you what would happen. Now again, the absolute value turns negative numbers positive and leaves positive numbers alone. So what if the inside was negative? Okay, what if it was negative? So let's look at that. And another thing that might happen is what if it was positive all along, and we need to see what happens for that. Okay, so distributing the negative 1 there, we have negative x plus 1 is less than or equal, less than or equal to 3. And I can start moving things around, so I can subtract the 3 and add the x. That way we avoid the confusion. So that'd be 1 minus 3, which is negative 2, is less than or equal to x, positive x. Okay, so that's one statement I need to look at. I need to add 1 to both sides, so I have x is less than or equal to 4. And I need to understand that. Now, let's draw our number line and see what happens. I'm interested in negative 2, and I'm interested in 4. I'm interested when they actually equal those numbers, so I need to plug those numbers in. Okay. Now, what you can do is you can test these 3 regions. You can test region 1, region 2, and region 3 and make sure that they actually work. So in region 1, what's a number that's less than negative 2? Well, negative 3 is less than, so I'll just try negative 3. Let's just see if I plug that in, what happens. Maybe I'll change colors. So if I plug in negative 3, which is just a number that's less than negative 2, I get negative 3 minus 1 less than 3. So what's going to happen is I have negative 4, absolute value is less than to 3, and we see that that's false. Okay, so region 1 is false. All right. Now you can plug in negative 2, but you can see what's going to happen is that it's going to equal perfectly, and that's going to happen for both of them. So this part's true, and this part is also going to be true. But we need to check for region 2 here and what happens there. So for region 2, again, I'll just switch colors. I need to pick a number that's in between negative 2 and 4. How about 0? That always makes the arithmetic easy. So the absolute value of 0 minus 1 is less than or equal to 3. That's the absolute value of negative 1 is less than 3. And that is true. 1 is less than 3. So this region is true. Okay. Now what about region 3 here? What about numbers that are greater than 4? So I need to think of some number that's greater than 4. How about, I don't know, 5? Let's try 5. So if x was equal to 5, you have 5 minus 1 less than or equal to 3. That's the absolute value of 4 is less than or equal to 3. 4 is less than or equal to 3, and that is false. So this is false. Okay. I guess just for completeness sake, I can plug in 4 and show you that that works. So 4 minus 1 actually equals 3. And so that's 3 is less than or equal to 3, and that's true because 3 is equal to 3. All right, so what did we find is true and what did we find is false? So we found that this region here is false, then 2 is correct. Then from negative 2 to 4 is correct, and after that is false. So that is a grand total of I'll just write an interval notation. We proved that from -2 to 4 is correct, and we want to include those points. Anything outside that region is false. Anything outside that region is false. So this should help you be able to prove to yourself of exactly how you can solve those types of questions. I think we'll have enough time to solve this one in this video, so let's do it. So you always want to isolate the absolute value first. So I'll divide both sides by -2. And then I have k4. And since I divided both sides by a negative number, I have to flip it. And this becomes +3. Now I have negative k minus 4 greater than or equal to 3. And k minus 4 greater than or equal to 3. So I can solve for that. Pretty much the same thing as the last time. Minus k plus 4 greater than or equal to 3. I can add the k to both sides, and I can subtract the 3 on both sides. And so I get 1 is greater than or equal to k, or you can write it k is less than or equal to 1. That's another way you can write it. So I need to identify that region. And also I can add 4 to both sides. I have k is greater than or equal to 7. And so I need to identify that region. All right. Well, I'm interested in 1 and 7. I want to include both of those points. Okay. And so both of those points, I would argue, are true because it's equal to 3. And then you just need to see where you are. So you have all the k's that are less than 1. So we need to check this region. We have all of the k's that are greater than or equal to 7. So we need to check, I'll call it region 3. We need to check that, but that's what this region is. Now, neither of these actually say that region 2 is going to work. So you can skip it, or you can plug in values here and actually test to make sure it works. I'm going to test the other ones. So for region 1, which is supposed to work for this, I need to test. So I need a number that's less than 1. Let's call it 0. So I'll plug in 0 and see what happens. Absolute value of 0 minus 4 is greater than or equal to 3. And so that's 4 is greater than or equal to 3, and that's true. So this region is true as predicted. All right, what about region 3? I need to pick a number that's greater than 7. How about 10? So I'll plug in 10 and see what happens. If I plug in 10, 10 minus 4 is greater than or equal to 3. 10 minus 4 is 6. The absolute value of 6 is greater than or equal to 3. That is true. This region is true. These are both going to equal 3. So we can say that that's true. And then if you plug in a number between 1 and 7, I don't know, say 3, you'll see that it's not going to work. I guess we can show that and make sure that that is true, but let's just pick 3 and see what happens. So 3 minus 4 is greater than or equal to 3. That is going to imply that the absolute value of -1 is greater than or equal to 3, and you can see that that's false. So this region is false as predicted. Okay, screen's pretty full now. But what is our final answer? It's the region from -infinity to 1, including 1, and 7 to infinity. So I'm going to go down here. I'm going to erase this example for the next video, and I'm going to write the final answer as -infinity to 1, including 1, and we want to say and, nope. No. We want to say or 7 to infinity as the final answer. That should do it for you. Okay. Sometimes we use a fancy symbol called the union, but we can just write or for right now. So -infinity to 1 or 7 to infinity, including 7. Okay. That's enough for this video. We're going to keep going in the next video about inequalities that include the absolute value.